Hello everyone, my name is Sena and I'm currently a PhD student in construction management at the University of Alberta, and today I will be presenting to you part of my research related to the indoor environmental quality monitoring in off-site construction. So the off-site construction method has emerged as an alternative to conventional construction in an effort to industrialize the construction industry, whereby building elements are prefabricated in an off-site facility and then shipped to the site for installation and assembly. It is a well-established approach to achieving faster, more productive, safer, and more sustainable construction. Typically, an individual tends to spend about a third of their life at the workplace, emphasizing the need to create safe and healthy working environment. In off-site construction, the production facility acts as the workplace of the workers, as they tend to undertake the different activities of the building fabrication process. This setup in a controlled factory environment has paved the way into human-centric construction manufacturing. Human-centric construction manufacturing requires placing the well-being of the workers at the center of the production process. Well-being, in turn, can be defined as the way individuals feel, function, and how they evaluate their lives, and it covers various dimensions, including physical, emotional, social, financial, vocational, and environmental aspects. Achieving a safe and healthy indoor environmental quality is a core element of human centricity. This is known as IEQ. It is impacted by several dimensions, including the air quality, the thermal comfort, the acoustic comfort, and the lighting quality inside the production facility. Workers in these off-site construction facilities can be prone to uncomfortable environmental conditions due to the use of machinery, the loud working environments, the material cutting and preparation, and the use of certain PPEs. Monitoring the IEQ is the first step into achieving a safe and comfortable indoor environment that meets the required IEQ standards and regulations that are set by the different regulatory bodies. And this should be accompanied with a decision-making tool, which can be achieved by developing a real-time monitoring and alert system that can help detect deviations in the IEQ parameters that are not within the acceptable ranges. While the offset construction industry has been shifting more towards human-centric construction approaches, the IEQ applications remain very limited. Studies have shown that there is a direct correlation between IEQ and productivity. Individuals tend to perform their tasks more efficiently when they feel comfortable within their working environment, and therefore this must be addressed in off-site construction. As such, the objective of this study is to develop a digital twin system for the real-time monitoring and alerting of the indoor environmental quality in off-site construction facilities, which can help management take the necessary corrective and preventive measures in order to achieve a safe and healthy working environment. The developed framework to monitor the IEQ is composed of 4 phases. In the first phase, we have looked into identifying the different IEQ metrics that we want to consider in the model and what are the specific parameters that impact these metrics. In the second phase, we have looked into the data acquisition of these parameters of interest. What kind of sensors and devices do we need to use to collect this data, and how can we integrate this in the digital twin model? As for the third phase, we have looked into developing the digital model of the production facility and the case study. And in the fourth phase, we have looked into developing the alerting system, where we first looked into identifying the specific allowable thresholds for the IEQ parameters of interest, and then we have developed an online system that can allow the management to monitor these IEQ parameters and metrics in real time. We have considered 3 metrics in developing the monitoring system, including the air quality, thermal comfort, and acoustic comfort. And these are represented by various parameters such as the carbon dioxide and particulate matter for the air quality, the air temperature, humidity, and airspeed for the thermal comfort, and the sound level for the acoustic comfort. And these parameters can be measured using various devices such as the air quality meter, heat stress meter, air velocity sensor, and the sound level meter. Now, for each of the metrics of interest, a 3-level warning system was introduced accordingly. These indices, including the air quality, PMV, the predicted mean vote index for the thermal comfort, and the sound level index, were developed based on the thresholds and recommendations that were set by the relevant regulatory agencies, such as WHO, ASHRAE, ISO, and the EPA. And we can notice here for the indices that they have their own ranges, whereby the 3 levels represent good, fair, or poor. As part of the developed monitoring system, on the left-hand side here we have the physical environment, where we have the case study of interest, which is a wall fabrication production facility, and where we have the installment of the sensors that we will be using to collect the data related to the indoor environmental quality parameters. And on the right-hand side, we have the virtual environment of the case study of interest, as well as the online monitoring system. And these two environments talk to each other using a developed data integration flow. Now, this is a preliminary demo of the developed model. First, it will show us an overall view of the production facility, where each of the spheres represent the status of the IEQ metric of interest. We can see the colors changing from red, green, and yellow, and we can switch between the 3 metrics: thermal comfort, air quality, and acoustic quality on the left-hand side. And in this snapshot, we are moving into a certain station of interest, where we notice the 3 parameters at the top: air quality, thermal index, and acoustic index, how they are changing. And then we have the time series for each of these parameters of interest, how it's changing over time. In conclusion, this study has presented a digital twin-based system to monitor the indoor environmental quality of off-site construction facilities in real time, and we have looked into the air quality, thermal comfort, and acoustic comfort. The system can help the management in these facilities to take the necessary corrective and preventive measures so that they can ensure a safe and healthy environment for the workers. One of the limitations of this study is that the air quality index that we have looked at only considers the carbon dioxide levels and the particulate matter, whereas this needs to be further developed to include more parameters as required by the EPA, And another part of the limitations or ongoing works of the study is that the system needs further validation in order to ensure its reliability in practice, and it's currently being implemented in an actual case study to test its effectiveness. Here are some of the references that we have used. Thank you everyone for your time, and please feel free to contact me here at this email if you have any questions.